everyone. Thank you for listening to my talk about MySQL replication crash safety. My name is Francois. I'm a system and MySQL expert, and I work at HubSpot. At HubSpot, our mission is to help organizations grow better. We develop and offer tool online for that. You can visit our website if you want to know more. So this talk is not recent. The first time I gave this talk was 2 years ago. But the reason for giving this talk today are still very valid. Replication crash safety is a complicated subject. People are confused about it, and it did not get any simpler in the last 2 years. So 2 years ago, there were documentation bugs about this. They were fixed. But today, there are still documentation bugs about this. And I know because I opened 2 just a few days ago. So let's dive in and enjoy my talk about demystifying MySQL replication safety. So for today, it's quite clear. I will stay giving details about them. So introducing the subject, I will give details we're talking about, like replication safety, what are the problems. We'll specify things a little, PIDs and multi-threaded slave. We'll talk about durability. I'll define that a little. And we'll a few other subjects like MinervaDB, DID, and others. So, and a short closing remarks and the link bugs and everything. Terminology, I'm using the legacy slave terminology. Well, I'm planning to use the replica terminology, a little more advanced replacement. This talk, we'll talk about the slave in this slide, status, logs, master, and so, and also like the one that includes the master info table. It doesn't really make sense terminology in the context of this talk. And before diving in, there will be some recurrings in the talk. So ways to make safe should also, so safe by default, and we need a back recovery. So you'll understand why, but I wanted to introduce those. So overview of MySQL. So you can look on this on here. A commit happened, so to InnoDB logs, not necessarily in this order, and are the journal location. Like this is where they store everything in the database. Slave, thread that is connector and is downloading logs. Thread saves those binary log with a local buffer for the server of the transactions to be executed. And it's the SQL thread that action, the transaction, and then in InnoDB in the database, the storage engine of the slave. Only if logs is enabled, will write itself to be the master for it. So what is replication crash safety? So after a crash and the recovery slave, replication should be able to resume. We shouldn't have replication breakage. We shouldn't have like error messages in show slaves like duplicate key or row not found. It's okay if it rewinds a little in its state, like as long as it will be able to run replication and converge back to the state of the master. And now we talked about the slave. What about the master? Master can crash. Enter recovery, crash to master. It should be able to resume replicating. It's not always the case. This is also important. And this without sacrifice consistency. So we do not want silent data corruption between slaves, because there are some cases replication able to recover, but the consistency in compromised. We have data drift. If this happens, which is quite hard, this happens, we got like there wasn't crash safe. Types of replication crash. Slave will cover both in the time. So intermediary slaves that are also writing, they're both slaves. So with all this, an intermediate both replication cluster replication. I'm not talking about like engine, like one of the talking about crashes, and it doesn't. So transactional storage and tokens. Quick note before we dive. It's quite the thing is replications need to show that replication break corruption prove safety. The thing that I say with like make sure all this may long on some subject. I think I'm not, but like on subjects. New bugs we've seen that in the past. Crash safe before were introduced, now it's not. So like what I'm trying, it's good, and everything on replication, like be able to. So the Dolphin and the Sea Lion crash safety, I will not read, but see that master crash equal 8 of master crash safety. I like this, should be safe by, but there's our slave replication by default thing. So MinervaDB 5.5, the other crash safe, and this to understand all. And replication crash safety, we have to dive a little more into the details of how replication works. So the state of the IO thread is stored into what is called master info. And the state of the SQL thread is stored in relay log info. I'll have a diagram about this in the next slides. But if we look at status, we can enter info here lines and a position offset it that matched it. And the relay log info, both the real and the matching position of that slate. Like this is the idea, but we'll cover it a little later. My own opinion, file and position there. We need else to, and that's my binlog servers knew about replication. So in my 5, master and relay log info are files. So in the diagram, you can see at the left master info, relay log info files. And so when this making progress, transaction commits it and InnoDB writes it to the file, but to atomic. So the SQL able to press and track it in an atomic way. For the IO thread, sending some transaction and roster info at the same time. Also, IO thread will not flush time. I have to end flushing. IO thread writes something, SQL writes something in general to Linux operating system in memory. And when we ask the operating system, put this to disk, so to be able to stay on disk after a crash. So if we fix every time it reads a transaction, it's quite slow that after a crash, relay log match that they were before the crash. For all the MySQL is crash safe in 5.5. Before talking the solution of 5.6, there's 2 more parameters, sync bin log and flush log at TRX. So impact the durability DB and the binary. So equal something for the safest parameter means that the logs are flurry and action. So they're actually persistent on disk. Logs are always written operating system buffer, but they're flushed. Like if we put sync bin 0, like write the bin log to MySQL will not put those binary logs. So after a crash, we think. So InnoDB flush RX commit, and I will use it in the rest of the talk, equal to 1. InnoDB flush its log every action, so it's the safest and default. When it's equal to 0, InnoDB will write and flush its log every second. So it means here that if MySQL is crashing, like not even an operating system crash, MySQL is crashing, there will be data that stays in memory in MySQL for InnoDB that is not on disk. So this is obviously not crash safe. If TRX commit equal 2, InnoDB will write the log after each transaction. So this will serve a MySQL crash, but will only be flushed every second. So with an operating system crash, this data. Now that all that is defined, let's talk about MySQL 5.6 replication crash safety. So a reminder, 5.5 is not crash safe because there's no way to do things amicably. So we cannot trust relay log info. We cannot trust master info, and we cannot trust the relay log because that flushed. So 5.6 solves that by introducing atomicity for tracking the SQL thread state and its actual progress. So there's a new parameter called relay log info repository, which by default is file. So we're storing relay log info in a file by default, like 5.5, but you can set this to table. And this parameter allows for atomicity for the thread staking. So when the SQL will commit something to InnoDB, at the same time, it will update its state. Now we have atomicity between relay log and the there's absolutely no way to get atomicity for the IO. The relay logs are files, and it's impossible to add data to a file and update a file. Even if it's a table, we append data to the relay, then we need to commit something in table. So it's not atomic. So MySQL introduced something called log recovery, and we'll talk just later. Just something, there's this X that just has to sync relay log info, and relay log info is in a table, like this parameter becomes, is in SQL. Relay log recovery is the second of MySQL 5.6 crash safety. And there's like master info repository. Like I don't think it's very useful it brings nothing or replication crash safety in a table. I think it's put this in a table, like we don't have files anymore that are MySQL, but from a replication point of view, it's not. So relay log recovery. So by default, MySQL starts, it creates a relay log and the IO thread, downloading from the master and write it to the relay log. So that's the standard behavior, which is the default when recovery equals 0. Relay log recovery equals on MySQL will the master info discard the position of IO thread, and it is trustworthy. The SQL thread. Let's remember about show slave position in the relay log in the SQL state. That and it's the position of the IO, and because it's in a table, and then startup sets of the SQL thread, like the SQL thread, to the new log. SQL thread will assume the new will be downloaded by the that are trustworthy. It's from a trust. So the previous relay log untrustworthy, they're discarded. And that's for MySQL first implementation. But there are problems there, because this will be done on every startup. Like if it doesn't crash, we wipe and we have them from the slaves. It's something that is cool in all situations. So MySQL 5.7 changed much in relay log recovery simplistic, and there's defaults. 8 still simplistic. There are known problem relay log recovery. 2 bugs below after start. We'll have to down relay logs slave. Even that on and improve a little faults in MySQL info default to because we need this. Masters also set sure this is used, but relay log changed. I don't know, hasn't updated because it's simple. MySQL solution here would be to add it. This is implement a better and please make MySQL a default. We're done on the solution 6 crash. We will now exit with GT crash save and so let's start. So GTIDs are also used in MySQL 6. This is a very interesting technology that is very useful. You'll see that in a minute. We'll see in a minute. Works is that every transactions are the unique identifier when writing to the binaries. But that means that the G in the binary logs. So the GTID state and of the slave are now in the binary logs. And also, the IO thread states are now in the binary logs and the real. If you're using GTIDs for replication, you need a good GTID position binary logs. Also means that in 5.6 need log slave updates to use GTID. Optionally, you don't advise you to do this is to replicate a position in the SQL thread position. This file in the position anymore. This is a GTID. So for we repoint after failure when things thanks to GTIDs. Improvement relies on pre-ing of the GTID on the slave. Sadly, when you link your binaries, you need some you set sync bin log as an example. It means that the state of a slave will be after an operating system. So that means that GTID replication is crash safe with log not equal to, and that's because it means that if you GTID and if you want extra, you won't be crash safe. There's a 7059 for 5.6 open by Facebook that is GTID and that is known to bin log not equal to. So Yoshinori Matsuno's bug, and this bug to this day still not fixed. And also a bug that I found a few days ago is that the manual is not telling you that you need sync log equal 1 for GID replication crash safety. So I opened this bug, I reproduce a crash and a replication breach. And this is a very recent bug, so that this is when I say that the documentation is wrong at this subject. So GD with MySQL 5.6 to be crash safe, you need all those layers. So relay log repository to table, we're not just here. Relay log recovery, same thing for file and position. Sync bin log equal 1, and also be flush log at TRX equal 1. When we use sync bin log, something not to 1, so usually don't send to TRX commit. But for crash safe, we need those two to be equal to 1. In 5.7, the default bin log equal 1. Happy because now is safe by, so TRX commit was already equal to 1 for the default of 5, but sync bin log default was 0. So with the progress made there. But so we're still missing recovery to 1 to be correct. Was what was making before, like I'm still unhappy about. And so make sure that you want replication crash. So change this parameter for that MySQL will restart crash. See, MySQL 5 adds a table. It's GTID execute for track date. So or to remove the having bind log slave update to be able to use GTID. It's good because you don't need slave. But sadly, like that is every transaction, you don't have binary logs or update. Decided to update this table only log log slave update. So I don't know why for performance reasons that doesn't make a lot of already update transaction. The other table file in position for the SQL. It should be able to update the other table time. A big cost really is the mistake for operating system safety with sync bin log not one. So this is a bug only for 5.7. So it's the fault of Facebook bug to like make the replication crash safe with less durable setting. And in bug, I suggest to update the GTID execute table after each transaction. When you're running a GTID with sync bin log not equal to 1, after an operating crash, not just a MySQL crash. A MySQL crash is fine. Everything lives in the memory buffer. After an operating system crash, your binaries are truncated. You lost the ID position, so you should go backup. However, the file position of the SQL thread is worthy, so we might be able to do something with it. And like this is the voodoo method for saving a GTID after an operating system crash when you have low durability. So it's the invention that I made it so really well before you use. It involves not starting authentication on that slave, and then it involves the GTID position, not the like this is not compo. You have to know that it's and then you add the binary logs with reset to make sure that thing in your way. Use file and position start replication on the trustworthy file. Then you run a few transactions, start to have a GTID. You stop replicating the GTID state. Don't give you more details about how to restore GTID state. You should only submit it if you fully understand it, so that you should be able to know what you need to do storing the GTID state. And I blogged a little, so you can check my blog. Make sure you don't use this unless you really understand it. Like this is yeah, but it's full, so I wanted to share that with you. So MySQL 8 is GTID position in Eno. This was done in the that needs a reliable position. Like this is something I've been doing been doing that in 5.6 in their fork. Unclear if about ID replication safe with loader. There's an EnoDB work for others, so MyRocks or Tuk. And like remember something that it is built server level storage engine. And the ID position is it is like if we rely like we are being intrusive of MySQL, like in much better to GTID execute transaction. But MySQL 18 and net replication crash durability. One has to replicate that I open, and I was able with 2 and I was able 15, but I was not able to break replication with 17 and 8.020. So it looks like those, but there's a bug. I'm unsure what to think about. Now let's go into master replication crash. So we already saw that if we relax the durability of binary logs, we lose binary logs on the crash. We lose the GTID state on the crash. But what about impact on the master? So if sync bin log not equal to 1, you're probably also commit not equal to 1. And then after crash, binary logs will be out of them will have removed the previous, which might not be the same. EnoDB every second and flushing like being system wants. This is problem. Your modes will be different in different situations. So I wrote a blog post series about this. I'll go very quickly into what happens. So if a master crashes and didn't sync its binary log, a slave is probably pointing into binary logs that on. So on restart, the master will write a new binary and the slave will do nothing. So the slave vanished binary log, and because they rewinded its binary EnoDB position, the slave data than the master and state might not have the same data, And so it's broken every number of data. So it's big data corruption, like not cool. And slaves were not yet to the byte that are vanished. What will happen is those slaves will not break, like replication will break on those, but they'll skip actions that other slave will have. All data is corrupted here. Like this is pretty bad. With GTID, and in this example, I'm using GTID 50 to 60 that are lost after a crash. So the binary logs matching GTID to 60 are lost after a crash. So the master starts and only see 9 in its GTID. So start creating action in a new binary log, GTID 50, 51. And so have the old 50 and the new 50. So because the will reuse Gs after a crash, actually a reuse, like the binary one, so the master doesn't know that GTIDs were allocated. So it will reuse them. But the slave has seen those. So the slave, in this case, seen 50 to 8. So slaves reconnects before the master has reused 50 to 8. Replication will, the slave will have more data than the master and will break. But if the master already reused 50 to 50, and let's say it's at 60 now, so the slave that has the 50 to 58 will now down the new D9 59. But the slave knew old transaction and the as new one. So here is skipping new transaction. This is data corruption again, and this is obviously not good. So when you're running with sync bin log not equal to 1 on a master, the binary logs of master cannot be trusted after an operating system crash. So you should make sure that no slaves connect to such master after a crash. So the way forward here is to fail over to a slave, to promote a slave as your new master. And you can use online mode equal on or off, offline mode equal on to avoid slaves from reconnecting to a master. So if a slave crash with sync bin log not equal to 1, then its binary logs are corrupted. So you should like purge all those binary logs, like running reset master on this slave. But if the slave was using GTID, like you need to use the voodoo trick or you need to restore from the backup. And remember that intermediate master are both slave and master, so you need to consider both. So here are bugs related to this subject. Like GTID should be crash safe with less durable setting. Make running MySQL with sync bin log not equal to 1 safer. And the missing comment in the documentation. So now we've covered like the simple solution of MySQL replication crash safety in 5.6, GTIDs, we've covered master. Now we're left with parallel replication. So multi-threaded slave, MTS, is a great improvement for replication speed, introduced in 5.6. It's made better in 5.7. But in 5.6, multi-threaded replication is doing out-of-order commit on slaves. And what do I mean by that? So if I have transaction A, B, C, D, E on the master in that order in the binary logs, show slave status might be pointing to B. So it means A is executed on the slave. But C and D might also be already executed because of out-of-order commit. Like they could be in different schema, which is how multi-threaded slave is working in 5.6. So C is being C and E are being committed, B is being executed, and D is pending. So we have a hole on the state of the slave. This is the same thing in 5.7 by default, unless you're using logical clock parallel replication with slave preserve commit order, which is not on by default. And until 8.0.19, you couldn't set slave preserve commit order without log slave update. So that's a good improvement in 8.0.19 that Oracle did to allow slave preserve commit order on a slave without binary logs. But out-of-order commit has a problem. So it means that the file and position is not enough to track the state of a slave. So GTID allows to track a complex position, but file and position doesn't. So there's something like the slave worker info table, which is very complicated to understand. I'm not presenting it here. You can read the work log if you want to understand how it works. So without GTID, resuming replication after a crash needs filling the gaps. And this didn't work in early versions of 5.6 and 5.7. It was fixed since then. So recovery is doing start slave until SQL after MTS gap. But this needs relay log. And after an operating system crash, the relay logs are gone. So this means that my multi-threaded slave without GTID is not safe for operating system crash and out of order commit. So there's a workaround. You can set sync relog equal 1, but it's a performance killer. It really is not cool. Like you want multi-threaded slave to have faster replication, not slower. The state in the slave worker info could be used to recover. Like there's a way to do it. It would be very complicated to explain, and I don't have time for this. But if it's possible to recover, it means it's possible. If it's possible to recover manually, it means that it's possible to recover automatically. So relay log recovery should be able to implement this. So we're yet again at needing a better relay log recovery. So what about with GTID? So with GTID, parallel replication is replication crash safe, but you need to enable GTID replication. So you need to set master auto position equal 1, and this GTID, you need sync bin log equal 1, and you need TRX commit equal 1, unless you have binary logs on the slave. So yet again, an example, A, B, C, D, E, transaction number 10, 11, 12, 13, and 14. So the slave that has executed 1, 10, 12, and 14 before the crash. So after recovery, like everything's good, we don't lose because we're syncing on our logs, the slave will fetch 11, 13, and so on. But this needs bin log equal 1, which is slow. And if you're using threaded replication, you want things to be fast. So yet again, we loop at the problem of needing a trustworthy GTID position. And remember that the voodoo trick that I gave you before only works with in-order commit. So if you have slave preserve commit order to on with logical parallel replication, you can use the voodoo trick. And if not, like you can't, and like you have a problem. So we need better relay log recovery here. But I said it should be, I said multi-threaded slave should be crash safe. But actually, there's a bug about this. So this is a regression. I think it's a regression because I found that there was a problem. And that was fixed in 5.7.28 and in 8.0.18. So like, if you, unless you run like quite an old version, you shouldn't hit this bug. But this is quite important that you know that there's a bug here, which is a very simple workaround. I think this bug was introduced in like fixing the gaps, and it means that the recovery doesn't work well on version prior to that. And there's an easy fix. Like if you run stop slave, reset slave, start slave, it solves the problem. Like I think you should know this. Okay, we're done with multi-threaded slave. Let's now talk about like some other subjects. So low durability. So sync bin log equal 1 and TRX commit equal 1 are needed for master crash safety. And that was how we made MySQL I available in the past. But modern MySQL I availability doesn't rely on restarting the master. It relies on failing over to a slave. Also, flushing to disk improved in the past. Like my disks were 10 milliseconds. We had RAID cache that were very fast and good SSDs that were also fast, like 0.04 millisecond and 0.15 millisecond to put data persistently on disk. But the cloud came, and in the cloud, putting something reliably on disk is a network round trip. It takes 0.6 millisecond. So in the cloud, running with sync bin log and TRX commit equal 1 is not super fast. So a lot of people in the cloud are running MySQL with sync bin log equals 0 and TRX commit equal 2. So yet again, we go back at needing like GTID and reliability without sync bin log equal 1. And MySQL won't be like 100% cloud ready until these bugs are fixed. Like DBA always need to work around those problems. So we didn't talk much about MinervaDB. MinervaDB still store master info and relay log info in files. It's disappointing, but it always stores its GTID position in table, and that is good. So it means it's replication crash safe even with low durability. But its relay log recovery is really not good. Like if you want to know more, you can read my blog post about this. But MinervaDB has a very interesting feature. Like it has, if you're running with many storage engine like InnoDB and MyRocks, it has a GTID table in both storage engines. So you can read more about on the link below. About pseudo GTID, I'll go very fast on this. Like if you want GTID feature without using MySQL GTIDs, you can use pseudo GTIDs. And you can get replication crash safety with pseudo GTID if you're always syncing your binary logs and if you do in order commit. So it's good to know you can use this. So about complexity. So how to start on this? Like all this is quite complex. And even with all the complexity we add in this talk, like I want to point out that there are many tables to store replication information. The replication position is sometimes stored in files, sometimes in tables, sometimes in the binary log, sometimes in InnoDB. And all this is very complex. Like GTIDs are complex, edge cases are complex. Remembering all the content of this talk is complex. I really would like Oracle to then build complexity out of all this. Like we need something a little more simpler to be able to operate MySQL. And back to the binary logs, I think they're an interesting break for building a more simple solution. So in conclusion, all this is very complex. It has many edge cases. Things are changing, hopefully for the best, sometimes for the worst when bugs are fixed. And I'm sorry to tell that there's no short version on replication crash safety. On this diagram, every parameter here somehow is either thought to make replication crash safety when this is false, or they needed for replication crash safety. And I even forgot to. There's also slave parallel type and slave preserve commit order that are not on this schema. So I'll try to wrap this up. If you want master replication crash safety, sync bin log equal 1, TRX commit equal 1. That's simple. That's all you need. It's more complicated for slave replication crash safety. So some parameters never impact replication crash safety. So forget about those. Sometimes people think they're useful for replication crash safety. I don't think they are. Some parameters are always needed for application crash safety. Make sure you use them. And there are some special situations. And I think there are only 3 special situations. If you're using GTID with log slave update, then you need sync bin log equal 1 and TRX commit equal 1. If you're using GTID with out of order commit with parallel replication, so in addition to sync bin log equal 1 and TRX commit equal 1, you need master auto position equal 1. And if you're running out of order commit without GTID, then you need sync relay log equal 1, and it will be slow. So this is what I mean by out of order commit. Like you can read the description. You can use the voodoo trick if you're doing in order commit with GTID and sync bin log equal 0, TRX commit equal 2. And in order commit will happen in this case. So thank you very much for Daniel Nietzscher, who did a blog post on demystifying MySQL 5.6 replication crash safety. So all the diagrams in this talk are inspired by this post. So thanks, Daniel, for giving me the idea and the structure for those diagrams. All those are blog posts or talks from myself about this subject, so you can read more. We have a lot of bugs on this subject. Some are closed, some are still open. I think it's useful to have those to be able to know the history on this subject and to know a little more. So feel free to read them. And if you find a bug, please open it so it can be fixed. And there are more links on the subject that you can read if you want to know more. So thank you very much for listening to my talk, and I hope you will have a good rest of the conference. Thank you very much.
Hey, Jean Francois. Thanks for registering for MinervaDB Athena 2020. Good to have you here, man.
Oh, it's good to be here. Thanks for having me.
So first of all, let me formally thank you from Team MinervaDB Athena. This means great. I tell you why. Because it's the first time we are doing a conference at this scale. We've been doing a lot of meetups. We arrange a lot of meetups at customer premises, MinervaDB office premises worldwide. But this is something new because we are connecting with people even outside, and the speakers are from outside our current ecosystem. So everything new, and the support from you means a lot for me as an organizer, people who are the audience. That's great. Thank you, Jean Francois, for taking time in registering and talking for this event.
Yeah, my pleasure. I think I've learned a lot from conferences that I attended, so I want to give back and contribute to great conferences. So thanks for having me.
Wonderful. Okay. When you submit your talk about how you can build replication infrastructure more responsive. When I say responsive, the term, it's like how you can troubleshoot MySQL replication infrastructure more intuitively. There've been a lot of discussion. So most of these talks have been the committee of the event are customers, our followers in multiple media. So when I shared this, the question was like, hey, when we hear from someone like Jean Francois about troubleshooting MySQL infrastructure, right? What will be the guidance we can hear from Jean Francois, who can help us in understanding MySQL replication from bottom up, where how you can build it for a scale from a mid-size or from a very early stage MySQL replication adopter to someone who is already on MySQL replication on a larger scale. Do you want to share with us your stories? That'll be great.
Yes, so it's a hard question because your question is very wide, from very large internet properties to small startup, and the needs of those people and those companies are completely different. So there's no silver bullet, and it's a classic IT answer. It depends. It depends on a lot of things. But let me try to give two pieces of advices here. So for very large internet properties, you need to have a DBA on staff. So if you don't have one, just get a DBA. And make sure you provide all the help that this DBA needs. Let him attend to conferences, let him stay up to date and get training. And also, one of the help you can get is by having a support contract with a MySQL consulting company, or you can hire a consultant that are expert in the specific challenges that you have. So that's for large internet properties. So for startup, you probably do not have a DBA, and you probably do not have the right size to hire a DBA. So focus on your business. Don't over engineer your infrastructure, but consider getting external help. I think it's a common mistake for startups to delay addressing their MySQL problem, and then when they hire a DBA, it's very challenging for that DBA to fix so many problems that are now too big. So my advice for startup is start addressing MySQL problems early, when they're small and that you don't have too many problems. And like, again, consider getting help from MySQL consulting company or consultants. So yeah, I hope
got
it's
you, got you.
answers your question.
Yes, yes. So my second that a second question. The continuity of that conversation from me is like setting up a replication on MySQL infrastructure is quite straight. When I say quite straight, there've been a lot of documentations. I mean, like, hey, how do I set up MySQL master slave, master relay slave, delayed slave, synchronous, asynchronous, semi-synchronous replication, building up load balancer on top of it, which could be a HA proxy or proxy SQL or a MaxScale. The complexity get in when you have replication on production, right? Now, like, how you can be more responsive, like when you been like a very much more experienced person like you who have set up very large complex MySQL replication, how do you look forward to having maybe top 5 metrics you can't afford to miss, or you continuously keep monitoring, or you're alerted to on a on building a responsive MySQL replication infrastructure? You have something to share?
So you mentioned a lot of tools, and I'll loop back to that at the end of my question. And you mentioned monitoring. Yes, have a good monitoring to be able to monitor replication, monitor MySQL in general. But this is not just the job of the DBA, and this doesn't limit only to the MySQL and the database world. Like, good monitoring, like to become observability, it needs to extend to the application, and it needs to be in the scope of developers. So like to organization, like don't rely only on the DBA to have observability. Like this is the role of everybody. And I'll just talk about something I've heard about this. Like an example is the MySQL slow query log. So it's not related to replication, but it's interesting because like I know of a situation where an outage was caused by a slow query, and then DBAs were asked to make the slow query log available to everybody in the nice interface. And like DBAs are not good to develop like web interfaces. So obviously this is useful to have the slow query log in an interface, but it's very noisy. Like the slow query log only like log queries that are above a certain threshold, but some queries, like it's normal that they're slow, it's normal when it's abnormal when they take like a little more time. So this is not like, the slow query log is not a silver bullet here. A good solution in that specific situation is to build your observability in the application. And so developers should have a notion of how long a query should take, and they should specify threshold for like reporting warning errors and even aborting the query. So like this is monitoring and observability. Like back at best practices in replication, like avoid classic traps. And I'll mention a few classic traps, but like just to understand this, like I think everybody knows that in security, you do not re-implement your own encryption. Like you don't do that. So do not re-implement replication. Like it's like re-implementing replication like is not a good idea. Also, like another classic trap is naive retry logic. And an example is like always read from the primary, and then when the primary fails, read from replica. Like this is naive retry logic. You will discover replication lag when it's a bad time to discover replication lag, because you always go to the primary, and then when it fails, you go to a replica, and then oops, you haven't thought about replication lag, and then you have replication lag in your face. So don't build naive retry logic like this. Always read from replicas. And another naive retry logic in the context of replication is if you have a lagging replica, like fall back to another replica for reads. That looks like a good solution, but it will cause like bad things. Like if you have a few lagging replicas and then you overload your other replicas, then those replica will also start to be lagging. And I think you can see the cascading failure scenario here. And what scares me here is that some proxies and solution on the market are providing those features about retries and stop reading from some replicas without giving warnings. So it's like, don't do that. Like, stay in the best practice of replication. And as you said, like, MySQL replication is good old boring technology that is well understood, and that works very well. So that's good, but be prepared for surprise. And this is where I loop back to the tools that you mentioned at the beginning. Like, be prepared for replication breakage and make sure that you have a good toolkit to be able to solve problems. And the way you get this is by attending conferences, by reading blog posts, by chatting with other experts. So stay up to date to be prepared when things go badly. And when you have a situation that like you faced after the dust settles, ask yourself, how could I have solved this in a better way? And if this involves doing a feature request in MySQL, well, please do it. Like, we need more features in MySQL to provide us with easier operations.
Cool. The point what you told is something very close to most of our community discussions, right? If you are looking at MySQL replication, stop considering MySQL replication as a simple high availability solution. Look at beyond that. Look at like how I can scale horizontally reads across several slaves. I tell you, technically, this from an application engineer's point of view, the biggest concern they confront is like, hey, come forward with is like, look, I have wider range of updates. Like I have like 150,000 records I'm updating, and that's gonna take some time to propagate to the slave. And if I read slave, then I'm going to have an inconsistent data to read from there. Now that leads to adoption of load balancers like proxy SQL or HA proxy or MaxScale. But putting all these things together, roots to exactly what you said. Most of these load balancers are not raising a flag before they route queries to a slave nearby or farthest actually. So these are something, like someone as experienced as you who has been on the database infrastructure ecosystem for reliability, for scalability, for high availability, been working so far, right? So long. How do you run a, I don't call it a run book, rather a checklist, right? When I'm building a replication infrastructure, what do you think I should avoid? I should avoid from choosing a replication automation or replication operations architecture or logic. Like as you said, like do not reinvent replication. That's a great point. Like you don't invent a replication model. Rather, you just follow what works great.
So what you should avoid is just doing something in your corner without listening, without getting feedback from others, and without like having a good understanding of best practices. So attend conferences, read blog posts, and like you mentioned about like big updates. Like I have a full talk on this subject, and that talk was how Booking.com deals with replication lag. So go listen to this talk. Either me, Eric Ehrman, or Simon Mudd gave that talk, and it's recorded somewhere on the internet. And share your solutions and share your infrastructure, either in a blog post, and you'll get feedback on it. Like I don't want to tell you not to use a specific technology or not, because there are good reasons to use those technology in some cases. So if I tell you don't use group replication, like it might be good for Facebook not to use group replication, but for another company, it might be very good to use group replication. It loops back to the beginning, like have people that understand those things with you, get help, and understand your situations, your particular situation before applying a magic solution that you find on the internet.
I wanted this to be heard from your mouth. I tell you why. Often I get, hey, something. The replication gets more complex when I have larger data sets to manipulate or to update. I personally refer them to your blog post and your video post, which I think was there even in FOSDEM some year back in FOSDEM. Some RootConf, one of the open source database systems conference. I'm not able to. Good that you brought that up, and I want to hear that from you. And I appreciate if you can copy that that link if you could on the Slack. I'm also going to search for that. If I could pull that during your talk, I'm going to copy that on the Slack, because that's a big data for information for people who want to invest and research more on replication for reliability and for scalability. Actually, what in your experience was the most complex replication troubleshooting I've done? Maybe top two, like what really could have destroyed the entire data, the business, and what do you think saved it?
Yes. So I was once involved in a situation where like a bug in MySQL, and that's an old time, some time ago, ended up corrupting data on a large percentage of replicas. And we needed those replicas for read scaling. So like we actually had to let the application read from replicas that were corrupted. So we actually enable idempotent mode on those replica, like keep replicating, ignore all errors, and we started like restoring the replicas. Like that involved like a very large amount of replica, like tens of replicas that were corrupted this way. So for reference, like this bug is bug number 72610. I'll paste it in the Slack. And so like idempotent mode needs to be known here. Another solution would be to use PT slave restart. So like, those tools are useful to be known. And like I mentioned, do feature requests to your database vendor. Like I think we need a new replication mode here that is not just idempotent, ignoring all errors, and strict, break all errors. We need something in the middle, and I call this the convergent mode. So this mode is only useful in such a situation where like you don't want replication to break on row not found or duplicate key, but you'd like to fix your data. So if you get a row not found error on an update, with row-based replication, it would be easy to put the right data in the database, and that's where the convergent mode would be useful. So there's a feature request about this, but it's still not done. So like that's an example of a challenging troubleshooting experience. And I'll give you another, like this wasn't really challenging, like it's straightforward what we have to do. Another one that was way more complex, it's when I deployed MinervaDB parallel replication. And I was quite happy with it. Like I found earlier bugs, but that was in testing. But we got a very good replication speed improvement out of this. But a little later, I found out that some replicas were lagging. And like I thought, okay, what's happening there? And like there were bugs in early versions of MinervaDB parallel replication, and I thought it was a deadlock, like a classic deadlock that I saw before. And I reported that to the MinervaDB Corporation. Like I had a support contract with MinervaDB. And then Valery Kravchuk, that is also speaking at this conference, like he was assigned to this bug, and he made me realize like this is not a deadlock. Like InnoDB is working here, something's happening. And so long story short, like we realized, like, after testing this with debug builds in production, like Monty even got involved. And so there was a race condition in InnoDB that caused a full table scan on a primary key update. And we found that thanks to parallel replication made that race condition happen once a day. But this race condition was probably happening very, like, in other situations, and like, I think this bug affected other companies, but parallel replication made this bug obvious, and then we were able to reproduce. We found the bug, and the bug was fixed. And like, the collaboration here with MinervaDB ended up having a bug in MySQL that was solved. So I think this is an interesting collaboration between, like, MinervaDB and Oracle that shows that MinervaDB is actually improving the ecosystem, and I'm very happy to have competition here with MinervaDB and Oracle to make things better. So, like, the bug is 82968 that I will paste in the Slack. And, like, this was about a deadlock in MariaDB parallel replication. There are also still deadlocks in MySQL parallel replication. That's an old bug, number 89247. And very recently, somebody from Percona, I think he's from Percona, did a very good analysis on this bug and pointed out where the problem was. And hopefully this bug will be fixed. So this is another example of like, the competing vendor, Percona in this case, in the MySQL ecosystem that is making MySQL better. So yeah, I really like those examples where everybody comes and makes things better.
So well put. Like, the first one was a tweak where you needed to operate a corrupted replication infrastructure to make sure the business is not impacted. You have the data, you rebuild the fresh replication infrastructure with the data you collected. The second one was like completely collaborative approach where you can't be one-sided. Rather, it means that there is going to be a lot of integration with MariaDB when it comes to the MariaDB specific enhancements to the replication. Again, working core with the InnoDB of Oracle MySQL, and you as the end customer who reported this bug. This actually makes one clear line of statement, right? As a database engineer, architect, or database infrastructure owner, you are expected to work in silo most of the times, but that never leads you to that point that you don't integrate your systems with an external core committee or the committer ecosystem. Also very closely work with the support engineer. Like you said, like most of us are who work on MySQL MariaDB definitely knows, have been interacted with Valerie Krauchek and like super passionate about helping people, right? So putting it like like that means the community relationship matters a lot. Collaborative engineering is something that's very key. Third one is, like, as you started the conversation, like giving back to the community, right? You cannot conceal something which you found it or look out for an alternative solution. Rather, like you wanted to make the community, the core committers, to be aware that look, MariaDB parallel replication solution can be a solution for that, but look, the inherent MySQL MariaDB replication solution has a bug for this, which definitely conflicts with my data on our replication infrastructure. Thank you so much, Francois. I doubt anybody else can put this story so direct, so interesting like what you did today. This also is one direct way that like how deeply passionate you are in educating us. All of us follow your blog. Thank you so much for your effort in sharing your knowledge, speaking in several conferences, so selfless, working all these things in your working hours, and you're finding extra time for us.
And
thank you so much, Jin.
And thank you for organizing this event. Like, you're enabling knowledge sharing, and I'm grateful for that.
Thank you so much, Jin. Francois, it's great talking to you. Wishing you a Merry Christmas in advance, a great 2021, a good one where we all can move around, meet, travel, and be safe. Thank you so much.